Okay, today's lesson is 6.7. It is on the sine law. So today we'll be working with triangles that don't have a 90-degree angle in them. So after this lesson, I can solve for missing side lengths and angles in triangles without a 90-degree angle by using the law of sines. First thing, we need to go over how to label a triangle properly. We have done this in the past. Bit of review here just to make sure we're all on the same page. So first thing is blank are labeled with small letters. That would be the sides of a triangle. So if we look at this triangle down below, side R is across from angle R. Make sense? So then hence that the vertices or the angles are measured with capital letters. So across from Q will be small q, side length Q, and across from angle P will be small p, side length P. A little bit of practice here, obviously capital Z, capital Y across from Y, and capital X across from X. And a little bit more practice, side length, small letter, angle, capital letter, angle, capital letter there. Pretty straightforward. So once again, those primary trig ratios that we've been using all along, the sine, cos, and tan, and their inverse, they can only be used when we have a 90-degree angle or right angle triangle. So we can only use SOHCAHTOA, how we remember that one, with 90-degree angles. So if we look at the first example for today, we have a triangle ABC. So I'm going to draw a triangle ABC. It doesn't say it's a 90-degree triangle, so I cannot draw a 90-degree in there. I'm just going to draw a somewhat nice looking triangle here. Label that A, B, C. And it's saying find the height from C. Find the height from C. So if we remember way back to our geometry unit, the height of a triangle, it drops from a vertice, from an angle to the opposite side. And of course it meets that opposite side at a 90-degree angle. So essentially, I've taken this triangle ABC and I've split it into two triangles. And they now have a 90-degree in it. So we're going to use SOHCAHTOA in order to prove the sine law. So we're going to derive sine law, everyone's favorite. So I'm going to label some measurements here. Across from angle A, I've got side length A, small a. Across from angle B, I've got small length B. And across from C is this whole side, is side length C. So first thing it says to do is using angle A down here, we are going to solve for the height, or find the height. I'm going to label this H, the height. So that is angle A down at the bottom right. So if we take a look at this, opposite angle A is height. So first thing I'm going to take a look at is this green triangle. I'll highlight it there just so you know exactly what I'm looking at. So that green triangle, using angle A, we can use the sine law, or SO, in SOHCAHTOA, because we have the opposite and we have the hypotenuse, the hype over here. So temporarily, this is our op and this is our hype. So I'm going to set up this and say that, well, sine of angle A, or theta that we're looking at, is equal to the opposite of A, which is H, the height in this case, divided by the hypotenuse, which is B in this case. I'm going to rearrange this ever so slightly. You'll see why in 2 seconds. Sine A is equal to H, so I multiplied both sides by B. And now I have solved for H. I've solved for H in terms of angle A and side B. I don't know what any of these values are, so I can't get an actual number here, but that's as far as we can go. So now the next part of this question says to use angle B. So now I'm going to take a look at this triangle. I'll highlight it in orange here, from here to here to here. So taking a look at this 90-degree triangle, I'm going to use SO again. You'll see why in 2 seconds. Using SO at angle B, so if that's our theta we're going to look at now, opposite angle B, once again, is our H. That's our opposite. And now side A is going to be my hype to angle B. So I can say that sine of B, angle B, is equal to the opposite divided by the hypotenuse. The opposite in this case is h, the height of the triangle, divided by the hypotenuse. In this case, A is the hypotenuse. So I'm going to do the same step I did before and solve for h. So I'm going to say that A times sine B, so I multiplied both sides by A, is equal to h. And there, I've solved for h in terms of sine B, or angle B, and side length A. But once again, I don't know what any of these actual values are. So what I'm going to do here, call this equation 1, call this equation 2. I'm going to do a little substitution. Follow me. Sub 1 into 2. A little substitution. They both have that value h in there. So I'm going to set those two equations equal to each other. And I'm going to see if I can solve for anything else. So B times sine of angle A, make sure you get your capitals and lower cases correct, is equal to h. But I'm going to replace h with number 2, equation number 2, A times sine of angle B. Make sure that's capital there. And this is the basis of sine law. I'm going to do one more rearranging just to make our lives a little easier to remember, and say that we can divide both sides by the side length. So if I divide this side by B, then I can have sine A is equal to A times sine B. Of course, if I divide one side by B, I have to divide the other side by B. And now I'm going to divide both sides by A. So I'm going to divide this side by A, and I'm going to divide this side by A. I'm showing lots of work here. I understand if you skip a step or two. So we get sine A over A is equal to A divided by A is 1. So we get sine B over B. And this is the start of sine law. And we have sine of the angle A divided by A is equal to sine of the angle B divided by side length B. Now I'm not going to do this again, but you could imagine here I dropped the height from angle C. If I were to erase all this and I were to drop the height from, let's say, angle A, so if I were to drop the height from here to here, and this met at 90 degrees, this met at 90 degrees, I could do the exact same thing using angle C, and I would get them equal to each other once again. I'm not going to do that. I'm going to fill that value back in for people reading this. But we'll get the final equation of A sine A divided by A is equal to sine B divided by B. And we could have done it a third time with sine C divided by C, just for time's sake. I'm not going to. And you'll notice something funny is happening there. I've got two equal signs. We're going to take a look at why that is the case. You never need to use all three of these ratios. You only ever need to use two of these three ratios. We're going to take a look at exactly when and why that happens. And a little trick that makes your life easier down the road is this equation is the exact same thing upside down. So you can use sine B over B and C over sine C. And I'll talk you through when to use what equation, but the gist of this is if you always keep your unknown on the numerator, it makes your life a little easier. And you'll see what I'm talking about when I get to the next example. So sine law can be used when you know two angles in one side or when you know two sides in one angle. You need, I'm going to put a little asterisk here, make sure you write this one out, you need 3 of the 4 puzzle pieces. If you have no idea what I mean by that, that's okay. Let's get into the first example and I'll show you what I mean by 3 of the 4. You're going to hear me say 3 of the 4 puzzle pieces over and over. Just like when we were doing SOHCAHTOA, I said you needed 2 of the 3 puzzle pieces. Now we're going to step it up a notch and say you need 3 of the 4. So first example 1, given DEF with 2 angles in one side, find the missing values. So it wants a couple values here. So first thing I'm going to take a look at is what we need to solve for first. And all of these problems will give you one complete ratio and a part of another ratio. And what I mean by that is, let's take a look here. If I take a look at E, so side E, I'm going to write out sine E over E. If I take a look at that ratio right there, I know 1/2 of this ratio. The 1/2 of this ratio that I know, well, angle E is 50 degrees, but I don't know side length E. So I've got 1 of the 2 pieces of this ratio. So if I take a look at something that I know complete, I'm going to take a look at sine D and D. So let's take a look at this ratio, sine D over D, side length E. Notice how I have the angle, which is sine 34 divided by 54. Notice how I have 2 pieces of this ratio. In the sine E over E, I only have 2 pieces, or 1 of the 2 pieces of the ratio. So I'm going to set up my equation in a very strategic order to solve for my unknown and put that in the numerator. So if I use these 2 ratios here, my unknown is this E here. That's what I want to solve for, because I have one complete ratio and a part of another. Since we can see that E is in the denominator, I want to have it in the numerator. So I'm going to flip these ratios upside down. And follow me here. I'm going to say D over sine D, oh, capital letter, of course, is equal to E over sine E. And this is what I mean by you only use 2 of the 3 ratios. Like technically we could write F over sine F as well, but you only ever need 2 of these 3 ratios. So I'm just not going to use this one quite yet. So that way I only have 1 equal sign that I'm worried about. So D and sine D, I know this is 54 meters over sine 34. This is what we call a complete ratio. I have the numerator and I have the denominator. So I'm going to label those in green because you're always going to use one complete ratio. And this is the definition of having a complete ratio here, top and bottom. And then my next one is E is my unknown over sine E, which is sine of 50. So see here I have 3 of these pieces of the puzzle, and I'm missing this 1 piece of the puzzle. I'm missing E. And that's how we're going to use sine law all the time, is we're going to have 1, 2, 3 pieces of the puzzle, and we're going to solve for our 4th piece of the puzzle. It's easiest to solve for that piece of the puzzle when it's on the numerator. So to rearrange this equation, I'm going to multiply both sides of my equation by sine 50 to get that denominator out of there, sine 50. If I multiply that side by sine 50, I have to multiply this side by sine 50. And I'm going to be left with sine 50 times 54 over sine 34 is equal to E. So I've isolated for E on that side. Now this is just calculator work. In your calculator, in one step, don't try writing out all these decimals. Type in sine 50 times, some of your calculators will just do 54 divided by sine 34, depending on how your calculator works. Notice that, like, technically this is over 1, so this whole thing is the same as saying sine 50 times, so that is one thing, times 54, so I just multiplied my numerators, divided by sine 34, so some of your calculators might be easier to type it in like that. So 54 times sine 50 divided by sine 34, and so I'm going to see if I can remember that to type that in. 54 times sine of 50 divided by, I forget what I'm divided by, sine 34. So in my calculator, I'm going to hit divided by sine 34. Now I don't really, this will work just fine, but you'll notice my calculator, I can type in big brackets to put this whole thing on the numerator and then divide it by sine 34. And it just looks a little cleaner there. We get the answer of 73.975 or 73.98. 73.98 is equal to E, and that was in meters, I do believe. I can double check there. So we have solved for a side length of this triangle right here, E being 73.98 meters. This did say values, so it does want us to find all the values. So next up, I'm going to solve for, let's take a look at this one right here, F. So first thing I need is a complete ratio. I need a complete ratio to compare this to, and then I need 1/2 of another ratio, or hence 3 of the 4 missing puzzle pieces. So if we take a look at this for F and sine F, I don't know this angle. You're probably saying that's a pretty easy angle to find. So angle F is equal to 180 minus 50 minus 34 to get that third side of our angle. So we can get that 180 minus 50 being 30 is 96 there, looks like, degrees. So we have this angle right here being 96 degrees. So now I'm going to set up my ratio. I'm going to put my unknown in the numerator, and I'm going to compare it to a complete ratio. So I'm trying to solve for F. F is what I want to find. So I'm going to put that in the numerator, and I'm going to divide it by sine F. We can fill in those actual values in a moment. Now we have to compare it to a complete ratio. I do have E and sine E now because I just solved for it, but I'd rather use D and sine D because that was given to us. It's much more exact, whereas 73.98 I did have to round ever so slightly. So I'm going to use this ratio here between D, which is 54, we know, and sine 34. So here's a complete ratio. You'll see as I start filling out some values, F is unknown. Sine F, F is 96, we just solved for that. And then we have equal to G, which was given to us, 54, over sine of 34. So notice, once again, we have one complete ratio. So in green, this is a complete ratio. We have both the top and the bottom. Those are two numbers. We could divide those two, and we could get a decimal answer. I'm going to try not to give a decimal answer. I'm going to try to wait till the very end to round it, just so I'm not rounding mid-question there. So then we have 1/2 of this other one. We know what sine 96 is. It is a decimal answer. And we have our unknown F. So once again, we're just going to solve for our unknown. We solve for that by multiplying both sides. Let's multiply this side by sine 96. If we multiply one side of the equation by sine 96, we have to multiply the other side by sine 96. Sine 96 divided by sine 96 is just 1, and we're left with F isolated on this side. And we get 54 times sine 96 divided by 96, missed a number, divided by sine 34. Once again, we could write that out as two different things, but I'm just going to keep it as one. It's easy to remember to switch into my calculator. So 54 times sine 96 divided by sine 34. So that's 54 times sine 96 times sine 96. I'm going to put that all in brackets once again, because that whole thing is divided by sine of 34. My calculator is nice. It gives you that one line of feedback. You can see what you're doing. And we get the answer of 96.038. Just going to make sure I type that in right. 54 sine 96 sine 34. Looks good to me. And we get the answer, sorry, of 96.038, so 96.04. 96.04. And that's, once again, in meters. So then we can take a look at our original question. 96.04, it's a little bit bigger than our other two sides. So if we take a look at our other two sides, 54 and 73, does it make sense that F is larger than those two sides? And well, if we take a look at the angles here, we know that across from the largest angle needs to be the largest side. So 96.04, slightly bigger than our other two sides. Hey, at least we're in the right ballpark. If we made a silly little error somewhere along the way, that might have happened, but at least we didn't get an answer that was smaller than 54 or 73, because then we would know we're not even in the right ballpark there. Okay, let's try it. Example number 2. Given triangle DST with angle D 47. So let me draw a diagram here. Nice triangle. Once again, we don't know there's any right angles in here, so we can't draw a right angled triangle. Clearly, this is not going to be to scale. I'm just drawing a standard triangle here. DST. Angle D is 47 degrees. Side length D is 78 degrees, so D must be across from angle D, is 78 centimeters. And S is 106, so S needs to be across from angle S is 106 centimeters. Of course, you could have labeled this triangle slightly different, but you'll get the same ratios. So what I mean by that is that if we're going to set up our sine law, obviously we don't have A, B, and C, we have D, S, and T. So we can set up our ratios and saying, like, hey, I'm going to solve for angle S. So I want the angles to be on top. So I'm going to say that sine S over S is equal to sine D over D. We could also use this last one of sine T over T if we knew anything about sine T. We don't. So we can clearly see here the complete ratio I'm going to use is going to be this sine D over D, because I know the side length and I know the opposite angle. And then we're trying to solve for S, and we know that side S, we know this value as well, and this is going to be our one value that we are going to try to solve for. So there's our 3 of our 4 missing puzzle pieces. So I'm going to write sine S is our unknown divided by angle S. So this is our unknown. This is what we're looking for. And opposite that is side S is 106. And then I'm going to use my complete ratio of sine D, which D happens to be 47 here, over side length D is 78. So once we have 3 of the 4 missing puzzle pieces, we can rearrange to solve. So I want to isolate for S here. So this is what I'm trying to solve for. So first thing in the way of S being by itself is that denominator of 106. So I'm going to multiply both sides by 106 to get rid of that. 106 divided by 106, obviously that's going to be equal to 1. And we're just going to be left with sine S on this side. If I multiply one side by 106, I need to multiply the other side by 106. So I've got sine of S is equal to, I'm going to write the 106 first just for aesthetics here. 106 times sine 47 divided by 78. Remember, technically, I could write this off to the side. Technically, this is sine 47 over 78 times 106, but 106 is divided by 1, so I'm going to multiply my numerators, multiply my denominators to get the answer of 106 times sine 47 divided by 78. And then just like before, you're trying to solve for an angle here. So we're trying to solve for this missing angle, this s. So what's in the way of s being by itself is this sine. So to get rid of that sine, we need to inverse both sides. So we're going to take the sine inverse of both sides, and that's going to isolate s, angle s, it's capital S, all by itself. If we take the sine inverse of one side, we need to take the sine inverse of the other side. So I'm going to take the sine inverse of 106 times sine 47 divided by 78. It's quite a bit to remember to type into your calculator. If you've got a calculator with a bunch of lines of feedback, then you can type this all in as one. I'm assuming most of you might have to do this in chunks, so if you want to follow along with me, my calculator can do it all in one, but I'm going to do it in chunks and show you that answer key on your calculator. A lot of you don't use that. So first thing I'm going to do is the numerator. So on my calculator, I'm going to do, our numerator was 106 times sine 47. So 106 times the sine of 47. I'm going to hit enter here because my calculator stores my most recent one in the answer key. So that is 77.523492237. Do not write that number out. That is a rounded number. Let your calculator store that answer. So your calculator stores that last answer, and you want to take that answer and you want to divide it by 78. So here you can see my answer key brings up the last one, and I divide it by 78. Then if I hit enter again, it stores that number, 0.99389099278, in my answer key. So that number divided by 78. And now I want to take the sine inverse of all that. So I need to hit second function, sine inverse, and then I want to, of my last answer, so I'm going to hit answer there. My calculator stores that for me. And I get the answer of 83.663, so 83.66. So we can write in that answer, S is equal to 83.66. And that is an angle measurement. We only use the inverse function to solve for angles. So it's 83.66 degrees. Now, taking a look at the question here, I just want to give a rough approximate here. 106 is much bigger than 78, so it makes sense that the angle across from that side length is much bigger. This is 83.66 degrees, is much bigger than 47, because obviously the side across from a larger angle needs to be larger. So at least we're in the right ballpark. We might have made a rounding error somewhere or something like that, but at least our angle measurement wasn't below 47 degrees to give us the right ballpark there. Once again, the answer, or question, sorry, doesn't say where to round. So round to the nearest hundredth when in doubt. The question does not say. Number 3. Perimeter of the Bermuda Triangle. So use the information on the diagram to determine the perimeter of the Bermuda Triangle to the nearest 100 kilometers. So we have to set this up to find one complete ratio and a half of another ratio. So the first thing I see very easy to solve for in this one is that angle B. So if we take a look for angle B, before we even get started doing any trig, we can solve for that, saying that it is equal to 180 minus 50 minus 74. So solving for angle B will help us to get a complete ratio before we even get started. So what does that give us? 150 and 74 is 124. So 56 degrees looks like there. So we get the answer of 56 degrees for B. And the whole reason we're doing that is now we can see we have one complete ratio. We know angle B, and let's call this side length B. So if we're to set up our ratio, we can say that, okay, our B and our angle B is our complete ratio. Then let's solve for another missing side. Let's solve for side length S across from 74. So I'm going to say B divided by 1800 is B. Let's write it first. b divided by sine of b is going to be equal to 1/2 of another ratio. So the other ratio I'm going to use right here is s divided by sine of s, which is sine 74. So if we take a look at what I know and what I don't know in these ratios, I know b, I know sine of b, I know sine of s, I don't know s. So I have 3 of the 4 ratios here. So I'm going to go ahead and fill out some values. B is 1800 divided by sine of b is sine 56. S is my unknown, it's what I don't know, and sine of s is sine 74. So 3 of the 4 pieces of the puzzle. So I'm going to multiply both sides by that denominator to get that out of the denominator. Multiply that side by sine 74. Sine 74 divided by sine 74 is 1. So if I multiply one side by sine 74, I need to multiply the other by sine 74. And I get the answer of 1800. Technically, I guess I should write it out just not to confuse anyone. Sine 74 times 1800 divided by sine 56 is equal to s. We know we just multiply by the numerator, so technically that's the same as writing 1800 times sine 74 all divided by sine 56. Doesn't really matter which way you write it out. I just kind of find it easier to, not 56, to memorize, to type into my calculator if it's all written as 1, is equal to s. So 1800 times sine 74. Once again, if your calculator is good, if you have that one line of feedback, quite often you can type this all in once. If not, you may have to use that answer key. So I'm going to say 1800 times sine of 74. And here's where I can hit enter. It stores that answer in my calculator, so then I can do answer divided by, I forget what I'm dividing by, sine 56. Sine 56. It just makes it a little easier there. Hit enter, and we get the answer of 2087.08. 2087.08. 2087.08, and that's for side length S. We're halfway done this question. It does want the perimeter, so that's all sides added up. So we also need to solve for, of course, gray here, side M. So if we want to solve for side M, we need one complete ratio and then the M ratio. So I'm going to put my unknown in the numerator. What I'm going to try to solve for is side length M. My ratio will be over sine M, capital M, and we need to compare that to another complete ratio. Use the ratio that's given just because it's more accurate. We don't have to round anything there. So the ratio that's given was B over sine B. Sine 56. Oh, not filling out values quite right. Sine B. So notice if we go through this, we know half of them. So we don't know what M is. We know what sine M is. Sine M is fine of 50 degrees is equal to, same as before, B over sine B is 1800 over sine 56. So we have 3 of the 4 pieces of the puzzle, 1 piece of the puzzle, 2 pieces of the puzzle, 3 pieces of the puzzle. And we're solving for that last piece of the puzzle being M. So same as before, you're going to multiply both sides by sine 50. Some of you think about it this way, multiplying both sides by sine 50. Some of you think when you bring it over, you need to multiply. However you think about that is probably just fine. Stick to what you know. M is equal to 1800 over sine 56 times by sine 50. Once again, I kind of like writing it as one whole ratio, but that is absolutely just fine. So M is equal to 1800 times sine 50 divided by sine 56. Either way is just fine. type that into your calculator. 1800 times sine 50. Once again, some of you will be able to type this in all as one. Some people will have to use that answer key. 1800 times sine of 50. Here's where you can use the answer key if you want. So if you hit enter, it stores that in your calculator. And your type answer divided by, was that sine 50? Sine 56. Sine 56. Enter, we get 1663.23. 1663.23. M is equal to 1663.23, and there is M. Okay, making progress slowly but surely. So they want the perimeter rounded to the nearest 100 kilometers. So we're going to have to do some rounding. Try to keep your heavy rounding to the very end, so you don't need to round the mid-question to the 100 kilometers, because that's pretty inaccurate. But we know that perimeter is going to be equal to, what is that? B plus S plus M. B plus S plus M. In this case, 1800 plus 2087.08 plus 1663.23. Probably going to use a calculator for that one. 1800 plus 2087.08, 2087.08 plus 1663.23. Enter. 5550.31. 5550.31. And then this was rounded to the nearest 100. Notice that said 100, not hundredth. Nearest 100 kilometer, not hundredth. So we have to round to this decimal place right here. So, oh, sorry, that's to the 10th. We want to round to the nearest 100th. That's the 100 right there. So we have to take a look at the tenths column. Since that tenths column is a 5, we're going to round that up. So we're going to round this to 5600.00. And that's in kilometers, I'd imagine. Double check that. Kilometers, yes. Would be the perimeter of the Bermuda Triangle rounded to the nearest 100th. Questions, just shoot your teacher an email or ask next class. That's it for today. Next class we'll be moving on to the cosine law, working with non-right angle triangles again. Thank you very much.